Welcome, everyone. I'm absolutely thrilled to have you here for today's explainer. We're going on a bit of a visual journey today into the hidden mechanics of the web. Have you ever wondered how a server understands exactly what you want and where to find it? Like when you click a link or submit a form, how does that data actually find its way home? Well, today we are completely demystifying backend routing. Okay, let's dive right in. Here's our roadmap for this explainer. 1. The what and the where. 2. Static versus dynamic routes. 3. Powering searches with query parameters. 4. Going deeper with nested routes. And finally, number 5, versioning and catch-all routes. All right, section 1. The what and the where, the foundation of routing. To really understand routing, we first have to answer a pretty fundamental question. How does a server actually interpret your request when it first arrives? Notice how every single request is broken down into two totally distinct parts. On the left, you've got the HTTP method. Think of this as the what. It expresses your intent, your action, like whether you want to get some data, post new data, update it, or delete it entirely. Then on the right, we have the route. This is the where. It's the exact address on the server where you want to send that intention. So if your method is get and your route is /users, you're essentially telling the server, hey, I want to fetch data, and the specific place I want to fetch it from is the user's address. So what does the server actually do with those two pieces of info? Well, it processes them in a very specific order. First, it checks the method. Next, it checks the route address. And then it literally concatenates both of them together into a unique key. This unique combination, let's say a GET request specifically to /API books, maps to a very particular handler inside the server. That handler is basically a set of instructions that triggers the exact business logic and database operations needed to return your data. Those two things combined form this unique routing logic that will absolutely never clash with, say, a post request to that exact same address. It's pretty brilliant. Section 2. Static versus dynamic routes, extracting data from URLs. Now that we know how a server finds a fixed address, let's talk about static routes. A static route is exactly what it sounds like, a constant URL string without any variable parameters. Take /API/books, for example. Whether you're sending a GET request to fetch a list of books or a POST request to add a brand new book to the library, this string stays exactly the same. It never changes. It's constant, and it always points to the exact same type of data resource. But what if you want to look at one specific book or a specific user? That's where dynamic routes come in. A dynamic route uses placeholders. In server code, these are often denoted by a colon, like ID. Look at the URL API users 123. The server reads that URL, recognizes the structure, and literally extracts the 123 right out of the path. It then slots that 123 into the ID placeholder to fetch that specific user from the database. And honestly, it doesn't matter if the backend is built in Java, Python, Node.js, or Rust. This kind of dynamic extraction is an industry-wide standard. And this brings us to a really beautiful core philosophy of backend architecture, the idea that REST APIs provide a human-readable construct to routing. When you see a dynamic route like API/users/123 paired with a GET method, it essentially translates into a plain English sentence. Fetch me the data for the user with ID 123. It's incredibly readable, right? And that is completely by design. Section 3. Powering searches. Query parameters. Okay, so how do we send extra instructions to a server without breaking that clean, readable structure we just talked about? The answer is query parameters. These are key value pairs added to the very end of a route, right after a question mark. You can see it here. /API/search, query equals some value. Why do we do this? Well, remember that GET requests don't have a body to hold extra data like a POST request does. So if we want to pass metadata or user-defined search values to the server, we just append these key value pairs directly onto the URL. It is absolutely crucial to understand the distinction here. On the left, path parameters are for semantic expressions. They identify a very specific resource, like user 123. On the right, query parameters are strictly for metadata or modifications, like setting a search value or a page number. If you tried to cram a search value into a path parameter, like API/search/some+value, technically the server could process it, but it completely defeats the purpose of REST semantics. It's messy, it's hard to maintain, and it just breaks the readable rules of the web. So where do we actually use query parameters out in the wild? Honestly, all the time. A massive use case is fetching paginated data. If a server has 10,000 books, you definitely don't want to load them all at once. You might only want 20. So you use query parameters to say, hey, give me page 2 and limit the results to 20. We also use them for filtering by user-defined parameters or determining sorting order, like telling the server if you want the results in ascending or descending order. The client uses these parameters to request highly specific, manageable chunks of data. Section 4. Going deeper. Nested routes. Now we're going to look at how servers handle complex relationships between completely different types of data. Let's trace the path of a nested route step by step. Say we start at step 1, /API users. This returns all users. Now step 2, we add /123. Now we're looking at one specific user. Step 3, we append /posts. The server now sees a completely different handler and returns all the posts belonging to that specific user. Finally, step 4, we add /456. Now we have completely zeroed in on one highly specific piece of data. If we read that fully nested route aloud, it acts as a perfect semantic translation. Fetch the specific post with ID 456 belonging to a specific user with ID 123. We nest different types of information at different levels to express different semantic meanings. It's kind of like a giant puzzle that makes highly complex database queries wonderfully readable for developers. Section 5. Real-world safety nets. Versioning and catch-alls. Okay, so we have our architecture built, but what happens when APIs evolve over time, or when clients simply make mistakes? Imagine you've got a legacy web app currently running on /API/v1/products. It expects the fields ID, name, and price. But suddenly you have a new requirement to build a mobile app, and that new app needs the field to be called title instead of name. If you just go in and change the backend code, you're going to instantly break the legacy web app. Instead, you create a whole new route version, /API/v2/products, which serves that new data structure while leaving the old one intact. Why does this matter so much? Because it completely prevents breaking changes for existing clients. It also avoids messy, unprofessional route names like /API new products. But most importantly, it creates a safe window. Front-end engineers get a stable, predictable timeline to migrate their code over to v2, while v1 is safely and slowly deprecated over time. It's a lifesaver. So we know how to safely upgrade our routes. But what happens when a request just gets completely lost? What if a user or a client app requests a route that simply doesn't exist, like a totally non-existent v3 endpoint? This is where the catch-all route comes in to save the day. Denoted by a slash and an asterisk, this acts as the ultimate safety net. It sits at the very, very end of a server's routing logic. If a request falls through all the previous route matching algorithms without finding a home, it hits the catch-all. Instead of returning a terrifying broken error screen that scares the user, it gracefully lets the client know they took a wrong turn with a nice, user-friendly route not found message. And that covers the incredible mechanics of how requests find their way home. Now that you know the difference between a static route, a dynamic path parameter, and a query parameter, you officially have the ability to read the secret semantic language of the web. In fact, look up at your browser's URL bar right now. Can you spot the path parameters and query parameters on this very page? Thank you so much for joining me on this explainer, and keep exploring.